Whether you like it or not, Rust is a language that is gaining massive popularity in both user space applications as a means to actually learn how to write Rust code, and also for lower level usage as well in places like systems programming. I and many other people have sort of floated around the idea of Rust one day being available in the Linux kernel, and I think I actually did a video on this a couple of months back. If I can remember what the video was called, there'll be a link up in that corner. There probably isn't a link up for that corner though. Now, until fairly recently, there hasn't been any serious work to actually make this happen, but that has changed. So back on April 14th, 2021, this email was sent on the Linux kernel mailing list. It is titled RFC Rust Support. Now, RFC basically means request for comment. Basically, this person is working on bringing Rust as a second language to the Linux kernel, and now that they actually have something to demonstrate, they're asking the Linux maintainers if this is something that would actually make any sense, or if the project should just be completely dropped. Now, I am no expert in Rust, and I am especially not an expert in kernel development, but nonetheless, I am really interested to see if this project actually goes forward. Now, I'm not going to be reading the entire email, and I'm especially not going to be reading the entire email thread, but there is some really good excerpts I do want to read, especially from what Linus Torvalds had said. Anyway, let's get into it. So first up, the author discusses a second language in the kernel, and he is fully aware there are huge costs and risks in introducing a new main language, and one of those being you risk dividing efforts. So basically, fracturing the kernel development and having one faction that is very interested in C and one faction very interested in Rust, and then having them not really work together. That is a concern, and I definitely hope that doesn't happen, but judging by some of the emails I've read here, it seems like the people who actually maintain the kernel actually do approach this as a group of adults. The other big issue, though, is increasing the knowledge required to actually contribute to certain parts of the kernel. Now, as for someone who generally needs to manage the kernel and make sure the patches being submitted are doing what they're actually saying they're doing, that actually would be a little bit harder, but when it comes to doing things like individual contributions, I think it actually makes it a little bit easier. So a lot of new developers never bother learning C. So introducing a second language like Rust, which is actually gaining a lot of popularity with people like this, does actually make it a little bit easier for people like this to actually contribute. However, there will be issues in sections where there's a lot of crossover between C and Rust, and you sort of need to know both languages to actually interact with that system. Now, one thing to note is this right here. We do not intend to rewrite the kernel core, nor the major kernel subsystem, so this isn't supposed to be a rewrite of the Linux kernel in Rust. That would be a dumb project. There's no reason to actually do that to the main project. What it's supposed to be is make it so you can actually write drivers and things like that in Rust if it makes sense to do so. Maybe one day a full Rust rewrite will happen, but it will be a very slow process if it does, replacing piece by piece as they need to replace them. Now, in adding Rust to the Linux kernel, there is a few goals they would like to achieve. The first one is a reduced risk of memory safety bugs, data races, and logic bugs overall. This is the general advantage mentioned whenever you bring up doing something in Rust. The next thing is that maintainers are more confident in refactoring and accepting patches for modules thanks to the safe subset of Rust. Also, new drivers and modules become easier to write thanks to abstractions that are easier to reason about based on modern language features, as well as backed by detailed documentation. And I brought this one up earlier, more people get involved overall in developing the kernel thanks to the usage of a modern language. That's not to say that C is a bad language and that C is outdated, but if we're being completely honest about the situation, most developers never have a reason to learn C, especially as we see more and more applications being developed for the web first. There's less and less of a reason to learn C, and as time goes on, you'll see there will be less and less C developers. Also, they would like to make use of Rust tooling to maintain the current documentation standards present within the Linux kernel. Now, Rust isn't the only systems programming language available, so let's find out why they're specifically going with Rust. So as is said here, no undefined behavior in the safe subset when unsafe code is sound, including memory safety and the absence of data races. Now, this part right here sort of rebuts this entire point, and I'm not sure why this was even included, because this relies on the unsafe code being sound, which is the exact same thing you're relying on when you're writing something in C. Also, a stricter type system for further reduction of logic errors. Now, C does have a type system, but it's very easy to break it if you don't know what you're doing. Also, a clear distinction between safe and unsafe code, and when you write something in a language like C, there's no way to really understand if it's going to be memory safe unless you know exactly how that code's going to operate. And I don't mean that you wrote the code and you understand what it's supposed to do. I mean that you know exactly how it's going to run. Also, Rust is a featureful language including all of these features here, most of which I don't recognize, but pattern matching and generics are definitely very useful, and I'm sure most of the others are going to be useful as well. Also, it has an extensive freestanding standard library including all of these things here, and integrated out-of-the-box tooling for documentation generation, a formatter, a linter, all based on the compiler itself. Now, Rust is still a fairly new language, so while some of this stuff might not be at the level that it is for C, just remember that back when C was first being introduced, C didn't have the same level of tooling that's available today. Now, because this is asking for a legitimate discussion, and it's not just saying that Rust is a panacea for everything, we also have a list of reasons why Rust probably shouldn't be in the Linux kernel. The first reason being there is years of tooling built around the fact that C is the language in the Linux kernel, but as I mentioned before, as Rust is actually being used more in a systems context, this will be improved over time. There is also only a single compiler based on LLVM, but there are some third-party efforts to actually address this. So there is a GCC front-end being made, a rustc backend based on CraneLift, and mrustc, a compiler intended to reduce the bootstrapping chain, and as time continues, there's probably going to be more compilers that exist as well. The language also isn't standardized, meaning that it's not entirely clear the direction the language is going to develop in, but as it says here, it's unclear whether standardization would actually be beneficial for the kernel. And the big one that a lot of people get hung up on is slower compilation, but this is due to the fact that it's a more complex language and also of limitations of the current compiler. So with a better compiler, this could potentially be addressed, but being a more complex language, it's obviously never going to be as fast as something like C. But this isn't really an issue for end users to worry about unless you're the very small group of people who actually compile their kernel. This is more of a development issue. Now, the current patch being discussed requires features from the nightly compiler, as they're not currently available in the stable version, but they would like to remove this limitation, and hopefully within a year, that is going to be gone. Also, the text being added is way bigger than it needs to be because there's a lot of things in the Rust standard libraries that will never be used in the kernel and need to be stripped out from them. Now, the author believes that a lot of these issues will be addressed as Rust matures as a language and gains more users, and he believes that as time goes on, Rust will become a very important systems language, just as C has been throughout the past couple of decades. And I definitely think this is going to be the case, especially as companies like Google actually stand behind Rust and bring Rust to their platform. So Rust is going to be the third language you can develop the Android kernel in, alongside C and C++. However, I'm no expert, so let's find out what Linus Torvalds has to say, and this right here was his initial response. And he starts off by saying that he doesn't hate the idea, but he does have a couple of concerns. So as he says here, I do think that the runtime failure panic is a fundamental issue. And what he's referring to is this right here, where if the system runs out of memory, then it will throw a panic. Now, what he says to this is if the Rust compiler ends up doing hidden allocations and they then cause panics, then one of the main points of Rustification is entirely broken. That's 100% the opposite of being memory safe at build time. An allocation failure in some random driver must never ever be something that the compiler just turns into a panic, and in a separate email, he describes this as being similar to what C++ does, where the new operator in C++ is completely broken. So effectively, his argument is that the Rust standard library is completely broken for doing systems development, at least with something like a monolithic kernel. However, the RFC author does plan to address this, as mentioned in this email right here. He understands that this is absolutely an issue and completely agrees with Linus, but he actually plans to rewrite parts of the standard library to ensure that this doesn't actually happen. And as Rust is used more and more in systems programming, it's likely that this is actually going to be addressed in the regular standard library anyway. With Linus not being completely against this, I think it's only a matter of time until we actually see Rust being a second major language in the Linux kernel. Because we can talk about C all day, but the world is moving forward and technologies are being built actually taking advantage of those decades and decades of experience that we actually have with C and addressing the problems that exist with it. And I can already predict some of the comments now. There is going to be some people saying, I'm just going to stop using Linux and this is terrible and Rust should never be in the Linux kernel. And that's entirely fine because every single system you're going to go to anyway is eventually going to bring in Rust, unless you want to go use something like Temple OS and live inside of Holy See. So let me know your thoughts in the comments section down below. I know there's going to be fights about this, but please just try to be civil. So I think that's going to be everything for me, but before I go, I would like to thank my supporters. So a special thank you to Joachim, Donald, Michael, Andrew, Nathan, David, Will, Brennan, Chickabento, Jamie, Joseph, Mitchell, Pittity, Stephen, Tony Tushar, and all my $2 supporters. If you'd like to go support my work, the links down below to my Patreon, subscribe, start, LibrePay, all that sort of stuff. I've got my podcast, Tech Over Tea, available basically anywhere, and then this channel is available on Odyssey and BitChute if you'd like to watch it somewhere that isn't YouTube. If you'd like to go and read this entire mailing list thread for yourself, there'll be a link to it in the description down below as well. So I think that's everything for me, and I'm out.